Our today's topic is bending moment. Definition of bending moment is the bending moment at any cross section of a beam is defined as the algebraic sum of moment of all the forces either left or right side of the section. See, one simply supported beam, one side roller and one side pin supports. Sorry for this is simply supported beam with one side pin, one side roller with uniformly distributed load. Free body diagram of this simply supported beam is free body diagram. That means we remove these supports and put their reaction to their supports. That means this is A, this roller is B, AY reaction vertical, horizontal, AX reaction, BY reaction. This is free body diagram with uniformly distributed load. This is simply supported beam and this is free body diagram of simply supported beam. Now at any cross section, consider this cross section XX, here also XX, here cut this cross section of a beam at a distance x from A and total length of this beam is L. Consider length of this beam L. Here cut this beam at a cross section. This is vertical reaction AY, this is AX, uniformly distributed load. Here C and this is BY, uniformly distributed load. So due to this uniformly distributed load, W per unit length, W, here also W per unit length. Due to this external uniformly distributed load, inside beam movement generates, and here see here the bending moment at any cross section of the beam is defined as the algebraic sum of moment of all the forces either left or right of the section. See here anti-clockwise movement mx and here clockwise movement mx generate. And see definition, the bending moment at any cross section, this is cross section xx and this is mx generate at cross section xx, is defined as the algebraic sum of moment of all the forces either left or right of the section. So this is left side of simply supported beam and this is right side of simply supported beam. So here this mx, bending moment at any cross section, this mx is anti-clockwise. Consider clockwise movement positive and anti-clockwise movement negative. Anti-clockwise, that means minus mx plus ay into this distance is x, ay into x, and ay we take movement at this point. See here this point we take movement, so this point, this mx goes to anti-clockwise through this point. That's why minus mx, anti-clockwise, that's why minus mx. This ay goes to clockwise through this point, that's why positive ay, and perpendicular distance to this vertical ay force is x, that means ay into lever arm x, and this is wx. Wx acting downward, minus wx, and lever arm x by 2, that means minus wx square by 2. Therefore mx is equal to ay x minus wx square by 2. And see definition now. The bending moment at any cross section, see bending moment mx at cross section xx is defined as algebraic sum of moment of all the forces. This is algebraic sum, positive, negative, negative. Algebraic sum of moment of all the forces either left of the section. See, we take left side of the beam, left of the section, or you may take right side of the beam, right side of the section. So this is bending moment. And why this bending moment occurs? See, this is point. See here, this point. Why at this point bending moment occurs? See, this ay force is vertical force. Due to this ay force, there is bending in this beam, bending generates in the beam. There is, due to this uniformly distributed load, due to this ay reaction, there is bending occurs at that cross section of the beam. That's why this bending momentum is also very important in structural design. At for simply supported beam, at center bending moment is maximum, and at that cross section maximum bending moment act on which cross section. For that cross section we design beam. Bending moment, see here, bending moment is equal to summation of forces, moment forces of the left side, or summation of moment over the right side. EMF left is sum of moment of all the forces on the left of the section. EMF right is sum of moment of all the forces on the right of the section. Now next, terminology: sagging bending moment and hogging bending moment. When clockwise movement on the left of the section or anti-clockwise movement on the right of the section is considered as positive bending moment. See, this is section, consider this is section, this is clockwise movement, and this is anti-clockwise movement. And here consider this is xx, and this is beam, consider this dotted line is beam, and this, due to forces, this beam deflect like this. There is convexity above the center line. See here, above the center line there is convexity in beam. That means sagging bending moment. Here anti-clockwise, clockwise, sorry, here left side is clockwise and right side is anti-clockwise. That's why there is sagging bending moment generates. And for this beam, which bending moment is generated, sagging or hogging? See here, due to this W load, there is beam deflect like this. See dotted line, beam deflect like this, and there is sagging bending moment generates due to this deflection. Hogging bending moment. See, for hogging bending moment example, see this is fixed beam with uniformly distributed load. How this beam deflect? This beam deflects like this way. At supports there is no deflection. That's why bending moment of this beam is like this: negative, negative, positive. This negative is hogging bending moment. See here, when anti-clockwise moment on the left of the section, anti-clockwise, and on the right of the section is considered as a clockwise. See here, clockwise. Due to this beam deflect like this, and this is hogging bending moment. Sagging bending moment is positive bending moment and hogging bending moment is negative bending moment. This bending moment terminology is also very important in structural design. Understand this bending moment terminology. Bending moment at any cross section of a beam is defined as the algebraic sum of moment of all the forces either left of the section or right of the section. Sagging bending moment, positive bending moment, hogging bending moment, negative bending moment. Convexity above the center line. See here, hogging bending moment, convex part. This is concave. Sorry, concavity. This is concavity. CONCAVITY. Concavity above the center line of the beam, and here convexity above the center line of the beam. Here convexity. Thank you very much.